So a complex number in general has a form a plus bi, where a is the real part and b is the imaginary part, with I acting as the imaginary unit defined as square root of -1. So looking at problem 4, the real part is going to be 6. The imaginary part is going to be a -1. Why is there a 1? Well, there's no number in front of the I, and it's not 0. Okay? There's a 1 right here. It's not a 1 because of the I. Remember, I by definition is square root of -1. If part B has you stumped, we could always rewrite it as 0 plus 3i. Because now you have an easier time seeing that the real part is 0 and the imaginary part is a positive 3. For part C, once again, if it helps, we can rewrite this as -6 plus 0i. This shows us that the real part is -6 and the imaginary part is going to be 0. Notice that in all of this, the imaginary part didn't have an I because I is an imaginary unit, and we're just looking at the real component and the imaginary component. Problem 5 is a very, 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 very important problem. This is going to help us figure out a lot of things in the future. So we're going to write the first 10 consecutive powers of I, beginning with the power of 0. So here are the first 10. You're thinking, what about I10? We start with 0. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we're going to prove what all of these are equal to. Brace yourselves. You may learn something. So let's start off with the first one. I to the 0. Well, what is almost anything to the 0 power? What is 1 to the 0, 2 to the 0, 5 to the 0? Anything to the 0 power is equal to 1. Mostly anything. I'll fix that. So I to the 0 in this case is 1. That was easy. Okay. Cool, cool, cool. What's I to the first power? Itself. Yeah. That's not a 2. That's an I. So 2 out of 10 so far. Okay. I squared. I squared. Well, that was defined a cool minute ago when we talked about I squared is equal to -1. So far, everything's looking pretty chill. Here's where the complications begin. I to the 3rd power. Here's I to the 3rd power. Now, we could say, and don't write this down yet, that I to the 3rd power is I times I times I. 3 times, because that's what the power indicates. However, because I know better, I'm going to write this instead as I times I squared. This still means that I have 3 i's, right? Because I mean, if there's a 1 power here, 1 plus 2 gives me the original 3. What about I to the 4th power? We could write that down as this, but again, this is not very useful. I'm going to rewrite this as I squared times I squared. What was I squared? So I have negative 1 times negative 1, which is a positive 1. All right, how about I to the 5th power? I could express this as I squared times I to the 3rd. I already know what I squared is. And I to the 3rd was negative I. And if we simplify this, a negative times a negative is a positive, so I get a positive I. For I to the 6th, I could do a few things, but I'm going to do I squares, just because this was easier for us. And how do you know what to pick, Mr. Over? I just kind of do. So trust me for this. For problem 5, I just want you to be able to understand what's going on. Okay, I'm not going to really have you do this ever again. But I need you to really, if you understand this and if you understand what I'm doing, you're going to be fine. So I squared, we said by definition, is negative 1. And here's another negative 1. And here's another negative 1. And if I multiply all three of those negative 1s, I get negative 1. I'm hoping by now you've had a oh moment or a what's going on moment. Hopefully you don't have a what am I doing with my life moment. Anybody want to guess what I to the 7th is going to be? Hint, are you noticing this? Oh snap. So according to our calculations, we should be getting a negative I for the answer. Let's try I to the 3rd, and let's try I to the 4th, since we've already gotten those. So I to the 3rd is negative I. I to the 4th is 1. 1 times negative I is negative I. Well, snap diggity. So the last two are going to be I to the 8th and I to the 9th, but I think you see the pattern now, right? I could say I to the 8th is 1. I could say I to the 9th is I. And you could even go more if you want, right? I to the 10 if it bugs you that much. And I to the 11. So if you need to have all those things filled out, well, there you go. Right? And so what you're seeing is it's the same pattern being repeated over and over again every 4 cycles. Now, this is kind of convenient because if I asked you right now for a test question, what is I to the 12th? I'm pretty confident you'd get this question because you have everything in order for you. But what if I went randomly and I said, what's I to the 51 power? Question mark. That means you're going to have to do 13, 14, 15, 16, 17, all the way up to 50, and then figure out what 51 is. That's just too much work. I agree. Okay, so we're preparing you to understand the pattern so that you can go ahead and enjoy the results of the pattern that we presented to you here. For your summary, what does I allow us to do mathematically? Think back to problem 1. Think back to what the calculator can and can't do and what you can do with I.